Hello, Randy Rain here, and some friends and I are putting together a show, and we're real busy right now doing that, but I still got to put a video out. So this video is about why I use pickaxe chips and to show you what this prop is and how I built it. And if you want to see the show, it's at the Farr Best Theater, December, Friday the 13th. What could possibly go wrong? It's called Holiday Havoc, Magic and Mayhem. It starts at 7 o'clock. Tickets are on sale already. You can get them at havocmagic.com. And before I get started, I want to say, yes, I don't build things that are super complicated, even though you could, and they are being used for that. These things are in space right now. But I want to show why I use pickaxe chips and why maybe you should too. So what I have here is a steel rod, the kind you get at the hobby store. It's called like piano wire is what they usually call it. And if you get it hot enough, you can actually solder to it. And I've soldered a little LED to it here. Then I painted the whole thing and then soldered some magnet wire to it, and I've wrapped it around. And eventually I'm going to paint the whole thing again. So it's supposed to be blacked out, kind of a floating LED type of thing. But it's got a blink, and I can't blink it myself. This is going to hold some batteries. So there'll be a door that goes. I've got a switch that this is going to go to here. So my first argument for pickaxe chip is that they are just chips. That's it. You can get them in 8-pin, 14-pin, 18-pin, 20-pin. But most of the time, all I need is an 8-pin or a 14-pin. And in this case, I don't even need all of this. So I'm just going to go with the 08M2 pickaxe chip. So this is the pickaxe chip here. And this one, this pin goes to positive. This pin goes to negative. This pin can only be used as output, where this pin can only be used as input. This is where you program it, but you can use this one as an input if you need it. But it should be your last resort. Use all of these before you use this one, because you have to do a certain thing to disconnect it from the programming. But that's how you program it. It goes into there. These other pins can be inputs or outputs. Depends on what you make them. I only need one input and I only need one output. So I'm going to use the designated ones, which means these that are not getting used, they go to ground. On the input side, you have a resistor here and a resistor here, like that. This is a 10K, and it goes to ground. That's the pull down resistor. And then this is the input, which comes from positive here. Then you have your push button. Just a quick edit. This is a 1K here. So this is a 10K, and this is a 1K. When this button is up, this pin is getting grounded down to here. When you push this down, it's getting, the positive is going through here, ground gets pushed back to this side of the load, goes down, and that goes high. So this is either a 1 or a 0. It's a 0 now, push it down, and it goes to 1. So on the output side here, this is either going to be 1 or 0 as well, or positive or negative. So its normal state is negative, so you'd have to make it go high. And that would be a positive there. And so if I had this negative come out, go to here, and then here's my LED there. And so every time I make it go high, it's going to turn that LED on. It's that simple. But what if you didn't want an LED? You can put a transistor here. put a resistor there, maybe a 1K. And then this would go to ground if here. That is the emitter. And then this is the collector. And so when this goes positive, ground is going to go through here. And so this could be hooked to a motor here, ground, and then this side goes to positive. And so now when this turns on, this goes high, this turns this transistor on, allows negative to go through here, turns the motor on. Or this could be a light bulb, this could be a relay switch, this could be a solenoid, this could be anything you need it to be. If it's mechanical, be sure and put a capacitor between these two, just to keep things from messing up. For that transistor, the easiest would be a TIP transistor, and something like a 100 to, I think they go up to like 140, maybe. Any one of those be fine. If it has an odd number, a 115, it's the opposite. So a TIP 110, well, that's an NPN transistor. A TIP 115 is a PNP transistor. But these are cheap and they can handle anything you put to this. And that's how easy it is to do a circuit with a pickaxe chip. If you need more, do the same thing. These can come to transistors and whatnot. You can do more inputs like this. So the first thing to do, I guess, is to make my little battery connection. So I've made some little brass tabs. And they're going to go in like this. So now, put some CA glue. Now this is a good spot to use the baking soda trick. This works, but it's very, very hard, which means it's very, very brittle, which means it's not going to bend and give at all. And so that's fine here. Just going to poke a hole right through here. And I'll cover that up. Need a switch, so I'm just going to use both sides of this switch. And do this. I need a 1K resistor and a 10K resistor. And then this 10K has to go to ground. So from here to here will be the button. And then this other pin is for my LED. there. And this one can go through the top. And this is what you do when you leave your drill out in the shop. You don't feel like going and getting it. Okay, this is our input resistor here. One of these wires has to go to here. And then the other one has to go to positive. Put it right here. And that's all the wiring. This is the battery door, and it needs a little thing to get some grip onto it. It has a little bump there and a little dimple there. So that'll lock into place. It's my argument number 2, is how easy they are to program. I was born in 1971, and then if you look at when I was 16 years old, that was right in the middle of the 8-bit computer craze. So if you're around my age, you may have had one of these, Commodore 64. Or maybe you're like me and you had a Tandy Color Computer 2 and then upgraded to the Tandy Color Computer 3. Or maybe you had one of those TI 99. But if you had one of these, in order to do anything on them, you had to know the basic language. If you've ever messed with basic language at all, you can program these things. So first of all, you need variables. Every language has variables. In this one, they call them symbols. That's how you mark them. You're creating a symbol that is a variable. And there are 3 types of variables. There is the bit, the byte, and the word. A bit can be 0 or 1. A byte can be 0 to 250. And a word can be 0 to 65,535. But in this one, I only need 2 bits and 2 words. One of the bits is BTN, stands for button. The other one is PST, stands for position. And then I have random seed and random move in my words. That's for randomizing a number. We'll get to that. It's always a good habit to define your variables, even though PST and BTN are automatically 0 when I create them. But I went ahead and put those in, and I added random seed. This needs to be any number. It really doesn't matter. I'll get to that. But then there's the heart of the basic program, which is the do loop. When it gets to this, it's just going to keep circling and looping back over and over again. So in this loop, I need to check for the button. And this is where the button variable comes in. There is a button command, but I don't like to use it. Kind of confusing in my opinion. I rather do it myself. So the way I do it is I'm using pin 3. So I check it, and if pin 3 equals 1, that means the button is being pushed, and the variable BTN equals 0, then that is a clean press. You have to worry about the button being pressed more than once. And so now we're going to change the variable BTN to 1. So now it can't go here again. BTN would have to equal 0 to go here. And so here is where we're going to do the action. we'll come back to this part for now. You want to do else. So if pin 3 doesn't equal 1 or button doesn't equal 0, then it's going to come to here. Now we're going to check this. If pin 3 equals 0 and BTN equals 1, that's a clean release of the button. So we're going to reset the variable back to BTN equaling 0. And then we'll end if, end if. And then we can take all this right here, move it out of the loop, and then put a label onto it, put a return at the end of it. Then we can use a go sub function and go to that and clean up our code here in the do loop. And now we can create another function for blinking the LED. And so this is where it's going to check to whether it needs to blink or stay on. This is for the variable PST, the position. So it's either 0 or 1. So 0 is it's going to be on, and 1 it's going to be blinking. So if I put in if PST equals 1, then this is going to be for the blinking. But then I can come down and go to else. And down here, I know this needs to be going to high. And so this is the thing that the button needs to change. So now I can go back up to the button, and in my action part that I have here, I can put in if PST equals 0, then PST equals 1, else PST equals 0. So this means if PST is a 0, it's going to become a 1. If it's a 1, it's going to become a 0. And so that will allow this down here to change. So now if it does equal 1, first thing I need to do is randomize a number to know if it's going to be on or off. So I'm going to create a function for that. And this is a little confusing, but bear with me. There is no such thing as random, even in the real world, really. Definitely on a computer, there's no such thing. We have to mix up a number to seed the random to make it feel like it's random. So the easiest way I found to do it is use the time function. There's a clock running all the time. Just grab the number, whatever that time is. That's what this was doing. So the variable random move is equaling whatever the time is. Now the time could be 0, and this is why I'm going to make that random move variable equal the random move variable plus 333, just a nice odd number. Now the random seed variable is going to equal whatever the random seed variable is, and this is why it doesn't start off as 0, because it would always be 0. So I just put in a random number at 565, and then it's going to seed the random function and then come up with a whole new number. Then it's going to return. So I have it set at if the number is bigger than 21,000 and the number is smaller than 44,001, then turn off. If it's bigger than 44,000, then turn on. If it's below 21,000, it's not going to do anything, and it's going to stay whatever it was the last time it came through. And that will be the random blinking. And that is the code. Now that I have it programmed, it's time to upload it to a chip, which brings up my argument for number 3, which goes along with the first one, that it's just a chip, is only $4, and the other ones are $5. So the third argument is price, and that's a pretty damn good argument. Now to transfer it, you will need to buy their little USB cable. Their USB cable is not a normal cable. There is electronics in here that processes the information. But this is what I like to do, is get their cable, cut off the end of it, and then you can find the schematics online. All you need to do is supply the power and have the same on and off switch that I used. And you can see I didn't have the exact resistor, so I built it up. But here I'm using these ZIF sockets, which is 0 insert force or something like that. And then you have the battery pack on the back. And so you can make this thing here very, very cheaply. And then you can program all the chips you want and then just pop them in. So that's all I needed right there was a LED on a stick. But it needed to be able to light up and then blink, and I can just hold it because I don't need to be actually making it blink or anything because I'm going to be doing things with this hand. So this one has to be easy. So that's all this is. Why? Well, you're going to have to come to the show and find out, or hold on till after the show. I'll show you. Anyway, if you like this video, I sure would appreciate a thumbs up. If you want to see more stuff, hit the subscribe button. I would like to thank these people right here. These are the patrons. These are the people helping me out. These are the people bringing you this stuff so you can see the stuff that I'm doing and why I do this, and maybe it helps somebody. And that's the whole point. So I thank these people oh so very much. And if you'd like to become a patron, there's of course links and there's perks and all that. So thanks for watching. Maybe even come to my show.